Do you think the only way to make your Java code thread safe is by using heavy synchronized blocks or complex locks? What if I told you there is a cheat code, a way where you don't need locks, you don't need synchronization, and your code runs super fast because threads never fight for data? It sounds like magic, but it's actually a design principle used by the fastest servers in the world. Hi everyone, welcome back. Today we are cracking the code on thread confinement. Usually, accessing mutable data gives us headache of synchronization. But the smartest way to fix this is simply don't share the data. If a thread keeps the data to itself, no synchronization is needed. In this video, we'll go from basic confinement to the formal ThreadLocal class, and then we'll look at immutability, and finally we'll battle test ArrayList, SynchronizedList, and CopyOnWriteArrayList. So grab your chai, open your IDE, and let's dive in. Okay boss, let's start with the basics. Thread confinement. Thread confinement is basically a design element. The Java compiler won't force you to do it. You have to enforce it in your implementation. Think of it like this. If you have a chocolate bar, that is the object, and you lock it in your room, your brother can't eat it. That is confinement. Even if the chocolate isn't thread safe by itself, usage becomes safe because only you touch it. A classic example, JDBC connection objects. The JDBC specification doesn't say connections must be thread safe, but in a server, thread takes a connection from a pool, uses it for one request, and puts it back into the pool. While the thread holds it, no one else touches it. Simple, right? This is called ad-hoc confinement. It's effective but risky because if you make a mistake, the compiler won't save you. Let's make it safer. Let's talk about stack confinement. This is where an object is only reached through local variables. See, local variables live on the executing thread's stack. So what about other threads? They can't even see that stack. It's completely isolated. If you use primitive types like int or long inside a method, you couldn't break thread safety even if you tried. The language simply won't let you give a reference to a primitive variable to another thread. Just like encapsulation protects your object's data, stack confinement protects your thread's data. So the rule of thumb, keep the scope of your variables as small as possible. But wait, what if you need to access this data across different methods without passing it as a parameter every single time? Stack variables can't do it. This is where Java gives us a formal tool, a special class that acts like a private locker for your thread. ThreadLocal. This is a more formal way to maintain thread confinement. Think of a ThreadLocal like a map. It stores a separate copy of the value for each thread that uses it. When you call get method, you get the value you set. You don't see what other threads set. Using it is super easy. Create ThreadLocal instance. You do this once per thread context. Set the user. Here user is mapped to calling thread. Get it? Calling thread will get the value it associated with. But wait, we are in modern Java. Don't use raw types. Use generics so that you don't have to typecast every time you get the value. Let's go over a demo. Imagine a web server where each thread handles a separate user request. We can store the user session in ThreadLocal object so that each thread has its own session data. So here we have user session class which has user ID and role. We have session manager which is basically ThreadLocal manager. So when thread calls set session method, we get the mapping for caller thread to that user session details. And when thread calls get session method, we get user session value mapped to that thread. So let's simulate a scenario where we need to create user session for admin and customer. Request from admin is served by thread 1 and request from customer is served by thread 2. So each thread set, or you can say register the session in session manager. Let me trigger this application. So here you can see each thread has its own isolated session. Even though they share the same session manager, they have different sessions stored for each one of them. Since these values aren't shared, we need zero synchronization. But every superhero has a weakness. If you aren't careful, ThreadLocal can actually kill your application. If you don't clean your mess using this remove method, the data stays there forever. That's why we need to use this clear session utility once the task is done. In a server, threads are used. If you leave data in a thread local, the next user might see the previous user's data. Scary, right? So always use threadlocal.remove method when you are done. Also, we are in 2025 right now. Back in 2000, during servlet era, ThreadLocal was a lifesaver for request set. But today, with async frameworks and microservices, it's less central. We prefer explicit request scoped beans or context propagation libraries like OpenTelemetry. So, the confinement is great, but sometimes you need to share the data. How do we do that without locks? We use immutable objects. If an object's state cannot be modified, race conditions are impossible. Immutable objects are inherently thread safe. You can share them with million threads and nothing will break because no one can change the state. So how to create one? State cannot be modified after construction. All fields are final. And last, the class object is safely constructed and published. Don't let this object escape during construction. For example, string class in Java. You can't change a string once successfully constructed. When you concatenate, you aren't changing the old string. You are creating a new one. Look at this code. Because the field name is final, Java guarantees that once the constructor finishes, every thread sees the correct value. No synchronization needed. Notice also how there is no setter method. Once this immutable instance of user class is created, you cannot change its value. It's immutable. You can read it, however, using getUser method. Okay, theory is done. Let's start a fight. ArrayList versus synchronized list versus CopyOnWriteArrayList. Which one should you use? The answer might surprise you. Scenario is you have a list of users and multiple threads are reading and adding to it. So first, ArrayList, not thread safe. If two threads add at the same time, boom, either index out of bounds or worse. And here is the proof even without running the code. So as you can see here in the Java docs, that is, this implementation is not synchronized if multiple threads access an array list concurrently and at least one of the threads modifies the list structurally, it must be synchronized externally. That's exactly what synchronized list does. Collections.synchronizedList. It uses decorator pattern. It wraps the list and puts a lock on every method. It's thread safe but slow because threads have to wait in line. So here you can see all methods are synchronized by using this locks mutex. And third, CopyOnWriteArrayList. This is the cool kid. It uses immutability principles. When you add an item, it doesn't change the array. It makes a fresh copy of the array and adds the item and then swaps the reference. For read heavy system, it's lightning fast because there are no locks. But for write operation, it's expensive because first it holds the lock and then copy entire array list. So use this when you have many readers but very few writers. Before we wrap up, a quick tip on locking if you must use it. How do you create a lock object member variables in your class? Option A, private final object lock. This creates a lock per instance. Great if you want threads to access different objects simultaneously. Option B, private static final object lock. This is global lock for the whole class. Be careful. This can create a bottleneck where all threads in the entire app are waiting for one single lock. Also, let's understand safe publication. Even if you don't use locks, you need to make sure other threads see your object correctly after construction. You can use final fields, volatile keyword, or static initializers to ensure this. So to summarize, thread confinement is to keep the data on the stack or use ThreadLocal. Immutability, if you must share, make it unchangeable, and last, choose the right thread sep collection for the job. Using these patterns consistently while building your application can make your code safer and faster. If you found this video helpful, please give it a thumbs up and subscribe for more technical content.